In a previous video, we already came across in passing the idea of subpatches called abstractions in PWGL. In computer programming in general, and in particular also in a visual programming environment like PWGL, you easily arrive at a point where your program just becomes too crowded to leave it an endless sequence of statements. Yeah, for us as humans, it's more easy to read any information that is presented in chunks. And that's no different with computer programs. In a computer program, in order to make it more easy to read, it helps us to wrap it up in smaller bits. And indeed, computer programs, it is important to think already at this stage in the visual environment about the readability of your programs, because you actually spend some time and you use them and expand them also to read them. And for that, it just helps you if you better understand your own computer programs, your own patches. So in this video, we are introducing the idea of subpatches, of organizing our patches that they become more easy to read. And in order to do that, we first introduce some idea that we can easily see as something that belongs together. And we define that, and then as a next step, we wrap that up as an abstraction. So here's the idea I'm presenting. Let's say we want to have some way to translate frequencies into MIDI note numbers. And I'm putting up here some formula, not to scare anyone, but just to say we can translate formulas like that into PWGL programs. If you don't remember anymore from your days in school what this here means, log, don't worry, we just need to implement it. We are not going too much into details of the math there. Okay, we want to implement this as a computer program. The input is some frequency. Like, for example, we have 440 Hertz for the standard pitch for tuning. And we want to output it some MIDI note number, like, for example, for the A, that would be 69. So let's have some input. For example, some number box that represents our input frequency. Yeah, for example, let's start with 440 Hertz, which is this F. And then we divide this number by a certain value, we multiply that, and then, we divide that, we have the logarithm, and then we multiply that with 12. So dividing is easy. We take arithmetic, division, and we divide it by this value. Logarithm, though, is a bit more tricky. It so happens that if you go into the arithmetic menu here, then you find some logarithm box, but that logarithm box is not flexible enough for us. It has only one input, but we actually need to have two inputs, the logarithm, and we also need to set the base. If you come across something like that, chances are good that in the underlying language, in Common Lisp, you have already some function that's there, because if you have some basic math function, Common Lisp is rather good at math. It's just not part of PWGL. So one thing we can do is look up in the Common Lisp documentation This is basically the standard Common Lisp documentation. Look up there what kind of function we could use for that. So I'm going here to the master index and under L look for logarithm. And indeed here I find I happen to know that's not logarithm, but called function is called log. And there we find the logarithm, and the logarithm now has a number input and also a base input. The base input is optional. That's simply not part of this box. I can't expand this box. So how do we get the function we already know, Lisp knows, into our PWGL patch? There's a way for that, and that is we double click on the background, and then we can simply enter a Lisp function, for example, log. Sometimes, depending on how this has been used before, you might need to make sure that the right package is chosen, but if it's the system package, you have a good chance that any built-in function is there. And I press OK. And there we have the logarithm function. Now we can expand it. And this logarithm has some number and some base. The base we know is 2. And this result of this computation goes into the upper input. If you don't know what a logarithm is at this stage, I'm not going into the details of that in this video. In a nutshell, you might still remember what an exponent is, what it is to raise some number to the power, or what it is to have a root of a value, and this is another inverse operation of those. And now what's missing is multiplying this expression with 12. So that's relatively straightforward again. Arithmetic, multiplication, and multiply that with 12. And if I evaluate this whole sequence now, then you see the result is 69. Yeah, it's very slightly above 69. But yeah, so we can see that 440 Hertz is the MIDI key number 69. And now if we want to, we can play around with this and, for example, take the octave below C. Sorry, the octave below is exactly half. The octave below the A is exactly half of 440. So that's 220. That should be 69 minus 12. Add a digit. It's 57. It's another A. Before we now define the abstraction of that, just briefly coming back to using Common Lisp in general. In case PWGL is defined in the programming language Common Lisp, it's actually very useful for those of you who want to reach a more advanced level to know more about the programming language Common Lisp in general. And for that, I recommend a very good textbook, which is available, the whole book, online. Yeah, you find the book at this under www.gigamonkeys.com/book. Short word of warning, this is not related to music. This is introducing the programming language Lisp. So this is for those students who want to get at a more advanced level. But if you want to do this, this is a very good book for that. So now we have a patch that we want to turn into some subpatch, into some abstraction. How do we do that? PWGL, under the main menu, there is a box, abstract box. create that, I open the box, and I put everything I wanted to take from my original patch in there. I just copy and paste. Now it may appear somewhere in the box where you don't want to have that, and so sometimes you may need to make the whole box a bit bigger, but there we have now the actual program. Now all we need to do at this stage is add some input and some output for the box. Within this box, I can add an abstract input, and I can add an abstract output. Connect them. And now we have our abstraction. We can import 440 again, and this should output 69. Roughly 69. If we want to make sure that it outputs integers, we could add some rounding here. If we want to also allow for microtonal pitch deviations, then you might not want to have that, but if you are sure we only want to have integers, we could add some rounding. This subpatch already works, but as I said before, creating a subpatch, one of the main reasons to do that is to make your overall program more easy to read. And this subpatch is not necessarily easy to read yet. We don't even recognize by its name, Abso, what it actually is. So let's turn the subpatch into something which is a bit more easy to read. I right-click on the name. There's something on the edit box where I can change. It's actually not Abso, it's Abso1, but I can change the name. And let's call this frag to let's say node number or maybe. And then it has a name which explains what the box actually does. If I click on the name, you see the argument name. Usually the arguments have some names. Yeah, if I click the title, they have some names that explains what they do. This box does not have a name for the argument. We can give it a name. I double click here and I tell this is the frequency. Just call it frag here. And if I have this here and I click now, then you see the name of the argument input is shown there. I can also tell this what the name of the output is. Usually in Lisp, you should not have any white spaces in any symbols that name something like an argument, but these are actually strings in PWGL, so they can have white spaces. So this now, if you just see it like this, the whole patch already becomes a bit clearer. But additionally, I would urge you, whenever you create a subpatch, to add some documentation to make it later, if you want to use this a bit later, for you a bit more clear what this actually is. I add a comment by going to data, and there's PWGL comment box. And in the comment box, I enter what the subpatch does. Transforms frequencies into maybe node numbers. And of course, we did some round. I add that here with rounded. If I would have a subpatch that has multiple arguments, I would actually have something like args here and then explain argument by argument what they actually are for. We don't have that in this simple patch, so I can remove that. You need to, at this comment box, you need to explicitly include line breaks if you want to have line breaks. Unfortunately, that's not done automatically, so I can do that like this. And then I have some line width there, and I can make the whole box a bit smaller. You see the MIDI node number, it even explains the output there. It tells what the box actually does. So this becomes already more easy to read now than what we had here. Yeah, we can input our frequency here. And if I evaluate this now, it should get a rounded 69 as a result. If you want to use your abstraction in more than one patch, we use it at a later stage perhaps. The most simple way would be just to copy it, have a new patch, and paste it in there. Straightforward. Sometimes you might want to actually save it under a name and then load it under that name later. For that, if you control click or right click on the name of the abstraction, there is this entry here, save abstraction. And once you've done that, you can have a new patch, and then under the menu abstraction, we have it here now. Created that abstraction. Copy. To briefly summarize, abstractions help us to create sub-programs, and with sub-programs, our programs overall are more easy to read. And yes, you can have sub-programs. Within this, I might have another sub-program, another sub-patch in abstraction.